Hey everybody, so I wanted to go through the last three questions that are on your Hess's Law worksheet. Number 5 was particularly interesting, I guess, for everybody, but we're going to start with number 4. So I'm going to do 4, 5, and 6, and then I'll upload these for you. Okay, so if you take a look on the screen, this is number 4. So you have N2H4 plus hydrogen makes ammonia, and then it gives you all the individual steps underneath. All right, so the first thing we need to do is we need to identify the unique compounds, right? So that would be the compound that is present in one but not in the other equations. So the very first one, the unique compound, is going to be N2H4. So I'm just going to highlight that for you so you can see what I'm talking about. All right, and then we're going to take a look at equation 2 and take a look at what's unique there. The thing that is going to be unique there is going to be the NH3. It is only present in equation 2, but not in 1 or 3. Now, here's the tricky one. If you take a look at the third equation, we have 3 options, right? We either have hydrogen, which is definitely a no because it is already in the first equation. Okay, so we can't look at it that way. The other thing we can look at is CH2O, but nope, we can't look at that one because guess what? That's in the first equation as well. Same thing with CH4O. Okay, it is also in the first equation. So that cheat that I gave you to try and figure out what's going on, we are going to have to be a little bit more logical for this equation. Now, what I'm going to do is I'm going to take a look at the original equation, and I'm going to take a look and see what is not in the original equation. So if you take a look, the original equation is just N2H4 plus H2 makes 2 ammonia. So that means that CH4O and CH2O both are not present in the original equation, which tells me that they have to cancel out. So right now, if you take a look, they are for CH4O, they are both on the same side of the equation. Same thing can be said for CH2O and CH2O. They are both on the product side of the equation. So my brain says, man, I need these to cancel out. So in one of these equations, I'm going to need them to be on the opposite side. So I'm going to need CH4O to be on my product side, and I'm going to need CH2O to be on my reactant side. So now we know somewhere we're going to need to flip an equation. I am going to flip the third equation. And the reason why I'm going to do that is because if I were to flip the first equation, the other one that contains CH4O and CH2O, that would mess up my N2H4, which would be a problem. Okay, so now let's talk about the instructions. N2H4, right? It has 1 as its coefficient, and it is on the reactant side. In the original equation, it is on the reactant side, and it has 1 as a coefficient. So I'm going to leave that equation just the way it is. The second equation, I have 2 NH3, that's on the product side. In the original equation, I have 2 NH3, what's on the product side, so I'm going to leave that alone. We have already kind of talked about what to do with this third equation, and we are going to flip this third equation. Okay, so now what you want to do is write down your new equations. So the first one is going to stay the same. So let me see if I can get my pen a little bit bigger so you guys can see what's going on, right? So we have N2H4 plus CH4O makes CH2O plus N2 plus 3H2. Now, because I left it alone, that means that my heat is going to stay the same. So if it started off as minus 35, guess what? It's still minus 35. Okay, let's look at equation 2. Equation 2, and some of you guys may not have written this out, but I want you to be able to see it live and in color. Okay, so it is going to stay the same. So that means that my delta H is going to stay the same. Now, my third equation, my instructions say to flip it, so I'm going to flip it. So now all of my products become my reactants, and all my reactants come my products. So CH2O plus H2 yields CH4O. Now, because I flipped my heats, that means that if it is negative, it becomes positive. So instead of negative 65, it is now 65 kilojoules. All right. So now I told you guys to bring down everything and make sure everything cancels out, right? So let's bring down all of our reactants. We have N2H4 plus CH4O plus N2 plus 3H2 plus CH2O plus H2. Okay, and then on the other side, I have CH2O plus, N2 plus 3H2, and that'll be plus 2NH3. Let me make this a little smaller so I have some space here. Whoop. Plus, my iPad just got an attitude, plus CH4O. All right, so now we just need to cancel out what we need to cancel out. I have NH2 on, N2 on one side. I have N2 on the other side. I have 3H2 and I have 3H2. I have one CH4O. I have one CH4O. I have one CH2O. I have one CH2O. Now, if we have done this correctly, I think I got everything. This equation should look like your original. So let's see if it does. H4 plus H2 yields 2NH3. Okay, now since it does, this says if you want to find the heat of this equation, add up all the heats. So I have minus 37 kilojoules plus a minus 46 kilojoules plus 65 kilojoules. That leaves me with an answer of minus 18 kilojoules. And that is the answer to number 4. Hopefully that was helpful.